This problem right here, it's a composition. They want you to do F compose G at 1. So they want you to take 1 and plug it first into G. And how you do that if you're looking at a graph is you come on the x-axis. Yeah. When you plug 1 into G, it's like a table, x, y. 1 should give you a 4. So you go up until you hit G about right there at 4. But now that G of 1 is 4, so they want you to do F of 4. So you're going to take 4 and plug it into F, just go up until you find it. You had to go up 8, so your answer is E. This problem right here, the inverse. Okay, your function, step number 1, replace f of x with y. So y equals x cubed minus 5. And then there's just 4 steps you follow. Step number 1, interchange your x and y. So it's going to be x equals y cubed minus 5. And then undo the subtraction, solve for y. So I'm going to add 5 to this side, add 5 to this side. You got x add 5 equals y cubed. How do you undo a cube? You do cube root. The opposite of a square is a square root. The opposite of a cube is a cube root. So you have to cube root this whole side. So you have y equals the cube root of x plus 5. But if you start searching, that's not in your answers. C is kind of close, cube root of x minus 5. But they have morphed this. They morphed this cube root into x plus 5. And they wrote a rational exponent. Your numerator is this guy, so that's 1. And your denominator is the index, 1/3. Anything to the 1/3 power is the same as a cube root. And that matches up with B. So your answer is B. Next problem. Okay, the inverse. If that's your original, what do you know about the inverse? It has to have the point. You just flip them. So it's got to have the point 4,3. So a C. Okay, in your notes, this might be a good thing to have. How many of you guys just punched this in on your calculator and matched it? That's pretty smart. Street smarts. That's really good, actually. So the vertex, here's what you're looking for. If they give you a quadratic that is in this form, it's actually super easy. It's called vertex form. The vertex is your, these numbers right here are your vertex. So your vertex is going to be h and k. But it has to be in this form. It's got to be x subtract h. So this number, this value inside the parentheses, that moves your vertex left or right. This number outside of the parentheses, that moves it up or down. So the h moves kind of left or right. That's your horizontal shift. If it's a negative h, is that moving right or left? You go to the right. If it's a positive h, that goes to the left. But your k, this k right here, moves it up or down. So the k moves it up or down. So a positive k goes up and a negative k goes down. Or it would be, so the test, it would probably ask, I'd give you this and I would say Okay, this minus 1. A shifts it 1 to the left, B shifts it 1 to the right, C shifts it 1 up, or D shifts it 1 down. That's probably be more of what you see on the test. So this minus 1, you're going to start right here. That's your 0, 0. Does that minus 1 say go left 1 or go right 1? So go right 1, and this minus 1 says go down 1. So which of these graphs has over 1 down 1 for your vertex? It's got to be C. The last thing you need to know is which ones open up like A and C and which ones open down like B and D. If you have a negative out front here, it will open it down. So if you have a negative, your choices would be either B or D. So look at this next problem. Right off the bat, before you begin, which two choices can you eliminate? You can eliminate B and D, so now you got a 50-50 shot. So the plus 2, does it go 2 to the right or 2 to the left? 2 to the left, so you can kill C now. It's got to be A. 2 to the left, 2 down. The negative opens it down, and this 1/2 kind of stretches it out, makes it a little bit wider. Okay, this was the last one we did. So a long division problem. So if you've got 9x cubed minus 45x squared plus 1 divided by x minus 5, you're dividing by a binomial. So anytime you divide by a binomial, let's use long division. So ignore the x minus 5. Just look at your x. What can you multiply x by to have it end up at 9x cubed? So you're going to go 9x squared. But now you've got a 9x squared multiply both terms. 9x squared times the x is 9x cubed. But 9x squared times the minus 5 is minus 45x squared. Your next step is critical. You have to subtract. So you're going to minus this. Or just change the signs on both terms. That's going to turn into a plus. These will always eliminate. And this one also happens to eliminate. And so you bring down and you're left with 1, and that's going to be your remainder. So your answer is going to be 9x squared plus your remainder over the divisor, x minus 5. So that should be D. Okay, a cubed plus 9a minus 2 divided by a minus 1. So your first term is going to be an a squared, because a squared times a is a cubed. But now I got to do a squared times minus 1, that's minus a squared. Subtract them. That goes to minus, that goes to plus. These two cubes cancel. And you cannot combine a's with a squared, so you're just going to have an a squared and a 9a. So what times a is going to give you an a squared? So your next term is going to be an a times a, there's your a squared. A times a minus 1 is a minus 1a. But now you got to subtract them. So that changes to minus, that changes to plus. Now these are like terms, and they're a total of 10 a's. Bring down your next term, which is a minus 2. What can you multiply a by to end up at 10a? Times it by 10, so your next term is a 10. 10 times a is 10a. 10 times a minus 1 is a minus 10. But now you got to subtract. So that's minus, that changes to plus. That zeroes out, and this is 8. And you're done. So 8 is going to be your remainder. So it has to be B. A squared plus A plus 10. Yep, we're good. Okay. This equation, they want you to use the quadratic formula, but actually it's a lot easier if you don't. X squared minus 4x minus 63 equals a negative x minus 9. So your first move, regardless of what you do, you have to get everything together. Get everything on the same side. So I'm going to plus x to this side, plus x to this side, plus 9 to this side, plus 9 to this side. And I should have all together an x squared, a minus 3x, and a minus 54 is 0. And maybe if you look at your answers, A and B look kind of beastly. They're kind of intimidating. But C and D are really, really nice. And anytime your answers are nice, you don't need to use the quadratic formula. So your other route is to ask yourself, can I factor this? Can I rewrite this as the product of two binomials? Or if you use your template, you're looking for two numbers that times and give you a minus 54, but add and give you a minus 3. And there does exist two integers that multiply and give you minus 54, add and give you minus 3, and they're what? A minus 9 and a plus 6. So anytime this happens, it's actually a piece of cake. Your product is going to be x minus 9 times x plus 6 is 0. And if your answer is 0 and you're timesing those two things, what do you know x has to be? X has to be a positive 9 or a negative 6. So you should choose D. This one, though, I don't think works out as nice. So if you've got 20x squared plus 21 equals 9 plus 11x squared, get everything on the same side. So I'm going to minus 9 on this side, minus 9 on this side, and I'm going to minus 11x squared here, minus 11x squared here. So where are we? We're at 9x squareds, and then plus, are we at 12? Is that right? Equals 0. And if you try to factor, maybe let's try and factor and see if we can get anywhere. These both have a GCF. You could rewrite this as a times problem. If you rewrote this as a times problem, it would be 3 times x squared plus 4, and your answer is 0. So here's where it gets tricky. What would make this a 0? What number add 4 is 0? Okay, this guy right here has to be a minus 4. So right now, if you know that this has to be a minus 4, which ones can you eliminate right off the bat? You can eliminate D, C, and B. Why can you eliminate D, C, and B? Because the only way for x squared to equal a minus 4, what kind of number does x have to be? Has to be imaginary. So you're getting the impression maybe that this has to be imaginary, and the only one with imaginary answers is A. So let's maybe go back. So factoring it kind of really didn't get us anywhere, other than we know it's going to be imaginary. But if you use, what were we at? 9x squared plus 12. If you use A, B, and Z, so if we do use quadratic formula, A is going to be 9, B, there's not a B, so B is 0, C is 12. So you could quickly go x equals negative B, negative 0, plus or minus square root B squared, that's just 0, minus 4 times A times C all over 2 times A. So now you're at right here, you should have, what's the minus 4 times 9 times 12? What is it? Negative sum. What's 4 times 9 is 36. What's 36 times 12? Negative 432 over 18. So look, I mean, you could stop right here. The work is done. Because at this point, you're in the same boat. You know the square root of a negative 432 has got to be imaginary. And your only option that has an imaginary is A. So kind of if you use street smarts, you're done. Okay, what about this one? This one was depressing. This one I was hoping you guys would all get. So what do they want you to do on this one? Just take 1 and plug it into G. So if you've got a table, like right, if this is your table for G, they want to know if you plug 1 in, what do you get out? You should get 4. So here's 1. Go up till you hit G. 1 gives you a 4. Your answer should be 4. So that's B. This one was probably challenging because we haven't done it for a long time. So what's wrong with this guy as it is? 6. You can't have an imaginary on the bottom, and your way of fixing that is pretty clever. How are you going to fix it so there's not an imaginary on the bottom? You times the top and bottom by 1 minus I. You times it by its conjugate, because you're creating a difference of squares right here. So if I do 1 plus I times 1 minus I, something happens way cool. 1 times 1 is 1. 1 times a minus I is a minus I. I times 1 is a plus I. That's what is cool that happens. Those two zero out. But your last term, what's I times I? An I squared. And what is an I squared? A negative 1. It's a negative I squared. Oh, it is a negative I squared. Because I times a negative I is so sweet. That's a lot better. Oh, negative I squared. So I squared is a negative 1, but what's a negative negative 1? So your whole bottom should have 2. So now you got a 50-50 shot, but you're going to have to keep going. You can kill C and you can, well, maybe you can kill C and kill D. Maybe you can't, because maybe you can divide them by 2. So on top, maybe I spoke too early. You got to distribute. 6 times 1 is 6. 6 times a minus I, so minus 6I. Minus I times 1 is minus I, and a minus I times a minus I is a plus I squared. I'm out of space. So plus I squared. So combine your two middle terms. So you got 6. Do you have minus 7I plus a negative 1? Because I squared is a negative 1. So you should have on top just a 5 minus 7I. And then on bottom you have 2. And you can't divide either of those by 2, so it is going to stay just as a fraction. So that's B. Okay, a composition. This is the exact same question as what is h of g of negative 6. So you got to be flexible because you'll see it either way. What they want you to do is they want you to take negative 6 and plug it into g. So you're going to take negative 6 and you're going to plug it once right there, and you're going to plug it once right there. So g says whatever you plug in, you square it, and then you add 4, and then you minus 2 times whatever you plug in. But I'm going to replace those x's with a negative 6. So negative 6 squared, that's 36. Do your multiplication. A negative 2 times negative 6 is a positive 12, so you got plus 4 plus 12. So you've got 36 and 4 is 40. So you're at 52. But now you're going to take that 52 because you just found g of negative 6. That is 52. But now you're going to take that and plug it into h. So the rule for H says 2, whatever you plug in, minus 1. So you're going to plug in 52. 52 doubled is 104. 104 minus 1, you should end up at the end of the day at 103. So you should have A. And that is it.